Hello my friends, and welcome to my long-awaited video about living life, avoiding as much EMFs as possible, what I learned reading various different books, and the conclusions that I came up with. You might come up with the same conclusions. Long story short, I am one of those people that finds themselves to be electrically sensitive. What does that mean? I feel like with all this modern technology that it's causing a lot of fatigue and a lot of disease in our bodies that doesn't necessarily have to be there. Why do I say this? Is because I've read a ton of books and I'm gonna get along in the video, and also I find that when I use like my wireless internet for too long and it's too close to me, that I have kind of like this slight ache in my heart even. Maybe other people feel the same way, maybe it's just me, it could be psychological. However, if you really think about it, like my friends, is consider the placebo effect. Consider some people getting a sugar pill and getting cured from a disease because they think they could be. At the same time, having these invisible waves all around us, and the research kind of proves that it does affect people. And there's some people I've seen on YouTube that have to go live in the woods because they're just too electrically sensitive. Also, we have a lot of chemicals around us. We have chemtrails. We have cell phone towers everywhere. For example, I walk around my neighborhood and I see right on top of people's homes, right on top of people's apartments, these giant cell phone towers. And because they're on the edge of the actual building, it's most likely 5G towers. My conclusion is that partially that EMF signals and our electricity, also called dirty electricity, it could be to blame for a lot of ailments people have. So what I personally do is at home, I use wired connection as much as possible. Just like yourself, I'm used to using a smartphone. So let's say I want to check a message or check an internet app. I turn on the internet then, and then I go into, then I turn it right off, and all I have on my cell phone on all the time is just the cell phone connection. So I can still receive phone calls, and I could still get regular text messages, however not iMessages because they require the internet. I hope you enjoyed this video. I'm gonna do the best I can going through the different ideas and things that I've been exposed to come bring me to this conclusion. And the thing that I want to bring about is, if this affects at least one person's life, with the people who eyes to see and the ears to hear. I got a feeling that you might be one of these people that is trying to research the subject. However, it seems since Google has been ruined, it gives minimal results to what gives you the right information. A lot of the stuff is censored on Google, but that's a different rabbit hole to delve into. However, I wish for this video to stay up. Hopefully it doesn't get censored. However, if it does, you'll find it freely available probably on BRIGHTEON, BRIGHTEON.com, and possibly Odyssey. May this help others, and may it help a lot of also kids not to be exposed to this stuff and to be aware of it. Okay, so let's get into the video. In order to make this more scientific, we have to get introduced to the equipment we're going to use today. First, we're going to take an iPhone 11 Pro, an iPad, and the amount of electromagnetic signals it could send out. This is the Taiwan-made TES 593 electrosmog meter. What is this unit? This unit is basically one of these things that can measure how much electromagnetic signal is coming out of a device on 3 fields. Notice it's a tri-axis. I got this recommended watching a YouTube video where a guy does a mitigation for people's homes. He recommended this one. There's another one that's more popular on Amazon. It's crap. I tried it. I didn't like it, or at least it didn't work for me. This is the one I swear by, and this other guy swears by too. So let me put the battery in and let's see the background. So all my devices right now are set to airplane mode. So that means that all the wireless signal connections on them are off. This is the device. It has different units that you could use. Volts per meter somehow matters. However, regarding for wireless frequency, when you press unit, you have to go to this mu microwatts per centimeter squared. This is the background that we're getting when we have when we're just sitting here in the park. You know, we're living in a world where we have, okay, so that's the background. So because this is a checkerboard table, we could use this checkerboard as base location. So 5.7, when you lift it up, it's getting a lot more. Perhaps maybe this table has some sort of EMF blocking properties, because you see, it goes down quite significantly. So let's just put it down like this, or like this. Let's just say it's like this, to try to recreate it. And now let's turn on the cell phone connection. Let's recreate it. So let's say this is your head and this is the cell phone. Let's turn it off Wi-Fi mode to just have cellular mode. So you see the numbers going up, 1, 8, 13, 18. So it's much less than before. So let's go back down. So when it first finds the connection, it does a burst of signal. Let's put it on, okay. And now let's turn this off to this. It jumps. Okay, now let's try to turn on a Wi-Fi on this. And let's try to turn on Bluetooth. Okay, so we're getting 15, 16. All right, so let's see in this next clip how it works doing video playback from YouTube from the same location. 2% load. So this is playing the video, which is nice. What you're also going to notice is that if you move it even slightly, this is gonna this amount goes down. And if you move this over here, I gotta say it's much better, because especially I unplugged the fan on the bottom. It works perfectly. 21. Nice. I mean, I could turn Let's see over the meter. You won't even hear it. Okay. But this is a review about the MS-01. So yes, at low consumption. So we got 39 microwatts per centimeter squared. However, what does this mean? Like, well, even though that we're creating invisible waves that supposedly don't affect us, is not supposed to affect us. Most people don't know this, but you see this went down like 3 times. when the video is not playing. Okay, it still jumps up. It's probably buffering. You're probably gonna hear this all the time. And just think about it. People are watching YouTube videos all the time on their thing. But friends, one of the things you have to realize is that when you get further away from here, let's say I'm at this place. Okay, this is the background also. The device that I'm recording this on, it's also on airplane mode, so it's not supposed to be emitting anything. Yeah, so we got that. So you could see it jump up. And also this device is on. We got the LTE on it. So let's try. So I'm gonna turn off Wi-Fi internet off. Now, airplane mode. So we're back to the baseline of 10. Now let's turn it off airplane mode. I've actually seen a lot higher than this. Turn on Wi-Fi, wireless internet. Now this is gonna be where the spike you're gonna see. 29, 13, 14. So perhaps with a device like this, it's not such a big deal. Okay, it jumped up a little bit. Okay. Perhaps maybe it's supposed to be over here. Okay. Now let's try playing a video on the iPad. Let's see what effect it does and what the microwatts per centimeter squared is. By the way, everything else has airplane mode on, so this is the only device that's creating it locally. So now this is the video playing for my YouTube channel. Actually, it's not such a big deal. Oh, I guess that's where it was. 91, 23. Let me just put it to you this way. Having measured this stuff, it puts you to a different appreciation of what these different signals mean and what they have. You know, we have possibly a really good connection here. So perhaps we're not picking up everything. It seems even further away, I'm getting like 20. Closer to the iPad, we're getting a lot less. Perhaps maybe closer to the antenna is important. Yeah, that's where the bursts of signals are. 25, 26. So, the way my opinion regarding these signals and the signals that get emitted by phones and wireless devices is you don't have just an iPad. Probably just an iPad by itself is fine. However, you have probably that, a cell phone, and a whole bunch of other devices. You probably have a wireless telephone. You have Wi-Fi on. You have all these different smart home devices. Everything is communicating and is sending out bursts of frequency, bursts of energy that may affect your sleep. And I'm gonna get to how and why. You see, it just jumps around like that. So this is one of the articles that had an effect on me. You could read this. After several childhood cancer cases at one school, parents question radiation from cell phone tower. So Sprint wound up shutting down a cell phone tower in a Campus, California elementary school. I'm gonna have this also linked below. Her son lost all his hair. 5 months later, his friend and classmate developed brain cancer. This is children we're talking about. 14-hour tumor, and we have this, and here we have a picture of the cell phone tower. I mean, it's literally across the street from the school, and you had 2 kids getting cancer here. This is a CBS report in a mainstream medium. It is classified as a possible carcinogen. That is some evidence out there. We're not naive that there are other components, other environmental influences. Brain cancer, that's weird. He was probably holding the cell phone to his head. And you see, it hired engineers, and it met government and industry standards in all respects. So if we have a tower that meets government and industry standards in all respects, A, maybe they could be covering it up. B, it could be that the government and industry standards have kids in the school, 2 of them classmates. They probably had like maybe a window facing this tower. Who knows? Who knows where they got this maximum effect? So whenever you hear it's obviously itself is alarming. Of course, they had to put American Cancer Society. You know what's interesting? The more money they get, the more they continue this thing. There's very little evidence. Yeah, okay. Now let's look at this article from Business Insider. Bill Gates and Steve Jobs raised their kids with limited technology. So you have Steve Jobs inventing the most coolest thing, this iPad that we're looking at. I'm really excited that I have it here. But he didn't let his kids use it. So here's the different interviews. Psychologists are learning how dangerous smartphones could be for teenage brains. Well, those kids, that kid had a brain tumor, so possibly. World Health Organization, take them with a grain of salt. One study correlation between screen time and mental health impacts. Okay. But writing about smartphone might be the wolf of the decade. So you have Bill Gates over here, limited how much technology his children could use. In 2007, Gates, the former CEO of Microsoft, implemented a cap on screen time when his daughter started developing an unhealthy attachment to a video game. He also didn't let his kids get cell phones until they turned 14 years old. Okay, what does he know that we're not talking about? Did he read the same news article that we just had? Did he? Now, let's see this guy. Snapchat guy. So, an hour and a half of screen time per week on their kids. So, a guy that invented a Snapchat program that you're using on your phone all the time is literally limiting it to kids for an hour and a half. Maybe he doesn't want them to get some sort of damage like those kids that did in that school. He created Steve Jobs, wouldn't let his kids use it. So Steve Jobs didn't let his kids use the iPad. Why? Probably because it has a Wi-Fi connection and it probably affected negatively the health, and he probably knew it. And I'm going to show you exactly that Apple knows about it too, because it's actually in the disclosure on the device. Jobs, who was CEO of Apple until 2012, prohibits his kids from using the newly released iPad. We limit how much technology our kids use at home, Jobs reported to Nick Bolton. If Steve Jobs were alive today, he'd do it. CEO of Google's parent company, Sundar Pichai, limits the time his kids spend watching TV. Okay. Pichai told New York Times in the 28th that his then 11-year-old did not have a cell phone. So Bill Gates, 14 years old to get a cell phone. This one, 11-year-old, no cell phone. And then you have elite Silicon Valley schools are low tech. They have kids actually using pencils and paper and all that stuff. Meanwhile, they could have probably got an iPad for every single thing in life. That's the average according to the co-authors. attending classes in tree houses. So obviously these kids now, some low-income schools meanwhile have increased their tech usage by usage to help teacher shortage problems. Interesting. So what we found is that the tech billionaire guys, they don't let their kids use these cell phones and all that stuff. So perhaps maybe it's for the psychological, perhaps maybe it's also because of the physical effects these devices have. All right, friends, so here are some of the books, let's say most of the books that influenced the way that I think regarding technology, dirty electricity, and all the such. And then we're gonna get into some also online resources that I found. So let's first start with this book called Dirty Electricity. The synopsis of this book is this, is that modern electrical systems, the way that they use their ground wiring, instead of having a wire coming back to the power station, because that you need an extra wire, what they do is they have the wire going to ground. And even our ground is polluted with electromagnetic pollution. For example, there was an instance with some cows that weren't giving milk, and somehow nearby there was like an electrical substation where there was the ground wire going into the ground. They took that away, and they started giving milk again. And there was also an office where there was a woman that no matter how much she tried, she couldn't get pregnant. However, when they installed these dirty electricity mitigation devices, she wound up getting pregnant very soon after that. So this is a good book to read. So let's see, reading this book, very good book. Electrical engineer. Oh, the Stetzer. You want to order the Stetzer. It's kind of like a device that goes into your electrical plug. Long story short, see, the woman went on maternity leave. EMF levels. What does this mean? Basically, our own electrical system is hurting people and animals and all the such. Maybe it's affecting even honeybees and such like this. Okay, so dirty electricity. I even wound up speaking to this guy on the phone, really good. I probably should interview him. Very interesting guy. He also talks about how, you know, there's those EMF mitigation blankets. There's some sort of like thing you plug into electrical outlet that's grounded to the ground. He said don't use that because that winds up, because all the dirty electricity is going through that neutral port, that third plug on the electrical outlet. So moving on to the next book that you might want to read is The Invisible Rainbow. So long story short, for all the way from like the 1700s, whenever they figured out electrical stuff, like Ben Franklin flew a kite, attached a key to it in a rainstorm. He basically did the connection, did the study that the more places got electricity, the more certain diseases increased. The synopsis of this book is that with every increase in electrification of society, that people lived longer but sicker. And there was a certain group of people that wound up dying out. And in this book, he actually attributes the creation of the radio and radio networks and radio towers, to the 1918 the flu symptom epidemic, where a lot of people wound up going to the next world. So there's another book that just cites the stuff. I mean, how much stuff did they have here? Wow. I mean, I should probably reread this book. Cell phones and cell phone towers. Although cell phones and cell phone towers are best known as emitters of microwave radiation, the radiation is modulated at a bewildering array of much lower frequencies that the body as a radio receiver perceives. For example, is a telecommunication system, blah, blah, blah. See all these different waves. GSM technology, cell phones. I mean, look at all these different frequencies. So basically put, if you understand this correctly, the cell phone over here, it's one frequency or several frequencies to get the cell reception from the tower. It's another frequency, let's say 2.4 or 5 gigahertz for the Wi-Fi. It's another frequency for Bluetooth. And most of the time when people use these phones, they have all three on. They have the wireless internet, 4G, 5G, they have the Wi-Fi on, and they have the Bluetooth on because they're listening to the music on their Bluetooth headphones, which are actually putting a frequency emitter right next to their ear canals, possibly even also giving them cancer. I don't know. But I would rather not test it. I would rather not test myself and be the guinea pig for this technology, because I already see it. So even Apple computers, instead of only the polluted electrical power, the earth, okay. So that's the interesting thing too. There's also two types of electricity. The one that Edison invented was the DC direct current, and that's what our electrical devices like phones, computers, and all that stuff. Anytime you need a wall plug to, let's say, to USB, that's DC electricity. So you're actually converting the AC to DC. And Edison was much better at marketing his stuff, so he wound up kind of like, no, it wasn't. Yeah, Edison, was it Edison that made the AC current? No, that was actually Tesla that did the AC current, and he made the Niagara Falls power station from the waterfalls. So long story short, DC, AC, you could send on long transmission wires. It's a wave instead of being kind of like a smooth line. So it alternates. It has multiple phases, and that property of AC electricity, having the multiple phases, is what allows it to enter the body and create electrical currents in it. So unshielded seedling and mock shielded seedlings. Let's see what they had here. Oh, interesting. You see that they have a picture of this tower over here? Radar. Oh yeah, I think they also talked about how the policemen that sit in their car with the radar array, they're actually affecting their health like that. Also, when you're at the airport, people don't opt out. I've always said I opt out. Even when I was in Amsterdam, I'm like, I opt out. And I never went through the scanner, thank God. But I think this is, the idea is possibly to make people infertile eventually over the thing. So this book is well researched, well cited. I could probably continue on with this book forever. However, we need to move on to the next one. EMF to Dr. Joseph Mercola, he's the one that recommended this Dirty Electricity book. This book is really good because he talks about EMF mitigation techniques. And one of the things I think he might have actually noted is that the EMFs and electrical signals is actually causing us to have a bad sugar intake and possibly get fat. Maybe he talked about it, or maybe somebody else, but this guy Mercola, he does a lot of articles and a lot of stuff about Emotional effects of EMFs on kids. Cell phones, wireless enabled, all this stuff. Your toddler may start melting down. You have them phone to pacify him. So kids from young childhood age. I mean, look at all the research it had. So what he also tells you to do is to, how big is the wireless? Not a single insurance company that would sell a product liability that covered mobile phone radiation. Wow. So the insurance companies wouldn't even cover this. Lloyd's of London has refused to cover cell phone manufacturers against customer claims of health harms since 1999. Wow. Long story short, having watched the videos, is that actually there's no limit to the cell phone power that they allow here in the US. Possibly a little bit of mitigation of that in Switzerland. And I remember seeing an article specifically that Apple's iPhone 12 was banned in France because of too much radiation. Let me quickly find it. So here's the article, BBC. France has ordered Apple to stop selling the iPhone 12 for emitting too much electromagnetic radiation. On Tuesday, the French watchdog, which governs radio frequencies, also told the tech giant to fix existing phones. What's interesting is, right now, for example, I'm holding the iPhone 11 Pro. That's the last iPhone that doesn't have the 5G chip. iPhone 12 is the first one to have the 5G chip in it. And noticeably, because the 5G chip takes up space in the compartment, it has actually lower battery capacity, and it looks chunkier and uglier than the iPhone 11. It said that the iPhone 12 was rated as being compliant with regulations. So France finds it different. So basically put, I mean, this was in 2023, they banned iPhone 12. So what? We're up to like probably 14, 15, 16 now. And if they banned this phone, France holds iPhone over radiation levels. What does that mean? I mean, just think about it. You know, they found this phone to have too much radiation. Maybe it's because of the 5G, maybe not. I have no clue. However, I'm not trying to find out. But, you know, that kind of makes sense why those companies don't want to insure them. So if you go to iPad settings, iPhone settings, go to General, and then scroll down here to Legal and Regulatory, you're going to see this part. So it meets applicable limits for radio frequency exposure. So there is a limit. So they talked about SAR, something like this, something about tissues, and it says to reduce exposure to RF energy, use a hands-free option, such as the built-in speakerphone, headphones, or other similar accessories. So also this whole SAR radiation, the argument that the cell phone industry has regarding cell phone radiation, specific absorption rate, this thing, is that they literally took water balloons and they tested that water balloon wasn't heated too much by the cell phone signal in it. That was their test. They took a water balloon. They didn't even take an animal. They didn't take like a monkey or a rat and said like stick a cell phone to its head. Like, I mean, you could just probably tape it to its head and like make it have like a video play on Wi-Fi for like 24 hours a day and then see if it actually causes anything. So basically this specific test is industry made test, and they just fill out a form And we have to know that this regulatory agencies, they're in their pockets. So they put this RF exposure, they're talking about use a hands-free option such as built-in speakerphone. However, you know how many people put this to their head and don't use a speakerphone? And headphones, what kind of headphones? Are we talking about wireless or wired headphones? Because the wireless ones probably still have an effect too. How much of an effect? I don't know. No, nobody tested it. Nobody attached the headphones to a monkey. I mean, or something else that could test it, or a guinea pig, some sort of living creature. And we saw in that picture that a radar by itself was causing plants to like die. I mean, what can this do? You have the 4G, 5G, you have just too many different variables here. You probably can't even test it fully to see this. So you see, Mercola says, it's not difficult to envision a future in which telecommunication companies are forced to pay huge fines and watch their stock prices plummet as a result, something that could already happen to tobacco companies. I mean, this is just completely disregard current safety level. Remember, the current wireless that are FCC are based on short-term thermal effects they cause. This book is worth rereading. I mean, I'm glad I put some things, and here's the appendix. Here's all the articles this guy read. I mean, this guy's a professional. No wonder he's like a medical doctor or a PhD or something like this. Doctor. It's Dr. Joseph Mercola. It's not some like random Yahoo off the street. And speaking of doctors, let's read another doctor. This guy, I think he's a doctor. The Body Electric. So mind you, I read these books a while back, and now I just pulled them off my bookshelf to make this video about it and to tell you about it. So the synopsis of this book is that our body has an electrical system in it, and that electronics and electricity does affect people. So what can I say about this book? I remember reading in this book somehow, remember that reading that we had on that meter, the microwatts per centimeter squared? He found that there was a correlation where the people that were exposed to higher microwatts per centimeter squared, because there was like a radar installed to like look for ships or planes or something like this, and it like reflected into their house, that whole town wound up having a much worse reaction. Also, what he talked about here is medical studies that I believe in this book he talked about. This reminds me of that show called Fringe, by the way. Really cool, because that was like in 1985, 1986. I think this book is from 1985. So they did tests where I believe a child up to 7 years old, a human being, a human child, you could cut the finger off and the actual finger will grow back. That we actually have similar abilities to the salamander. And what he also did was he measured the polarity and the currents inside, let's say the finger being cut off or the wound, and it's there's something to the electrical polarity, the electricity that flows through that physical body part that caused the healing, that caused the regrowing of a limb. And they also did the test with salamanders and other creatures that could actually grow back certain things. And I believe by inducing electricity into certain body parts, they were able to regrow something. Even in long distant cousin, the frog, which is not supposed to grow things back, I think they were able to get at least some sort of a grow back feature using electricity through the body. So if we understand this correctly, the body has its own electrical field. The Chinese called it qi energy. And if we really think about it, my opinion, or it's based on a lot of people's studies, is that we're actually spiritual beings having a physical experience that has a physical body. The physical body has electrical signals in it. Like, for example, you have electrical signals going from the brain to different parts of the body through the spinal column and through the nerve endings that we have. We have the electrical signals being converted out of our eyesight to what the brain interprets as our visual and our smell senses and all these different senses. It's all electrical in the things. So what if I told you that alternating current, that's the electricity inside our bodies, that the AC electricity could actually cause currents to develop inside the body. And remember, I was talking about how electrical currents inside the body or some polarities of electricity inside the body cause people to regrow limbs. Perhaps maybe it could have other effects on other electrical places, let's say like the heart. Like the heart, when a person gets defibrillated, anyways, when the heart stops and they want to wake them up again, they put like 300-volt electricity through the heart muscle to kind of like squeeze it together to start it pumping back up again. So there is an electrical field in there, and it's right now in our modern society, it's under bombardment from various different sources. Our Wi-Fi signals, our cell phones, our computers. And one of the things that's neither here nor there, however, remember they told us to remove lead paint out of our paint. Perhaps that lead could have actually been shielding us from these devices. And it's kind of like stupid, like who has these children? Unfortunately, probably somebody does, but most children are not going to eat a lead paint chip from the ground, and neither most people would, and probably animals wouldn't eat lead chips either. So that's probably a cover story for having electrically unshielded homes. Why I say this is that there's electrical blocking, electric signal, or radio frequency blocking paint that you could buy. It's like this black paint that has an electrical current sensitivity, and it can block the signal from coming into your home. So imagine if lead paint could do that automatically. So let's move on to the next piece of evidence that I have come up with. So you see, this is the kids website, kids.nih.gov. So we have a government official website of the United States government. Okay. Can we get any more credible than that? Hopefully we could get more credible than that. However, it's probably at the top of the list, at least to the official story. So National Institute of Environmental Health Sciences. What are electric and magnetic fields? Blah, blah, blah. So we have electric fields. What are electric and magnetic fields? Electric and magnetic fields are invisible lines of force that surround any electrical device. Power lines, electrical wiring, and electrical equipment all produce EMF. Some people wonder whether EMF might have some bad effects on our health. We are exposed to EMF almost anywhere we go, at home, in school, in stores, and anywhere. EMF decreases rapidly as you get further away from the source. So here's that AC-DC connection. Alternating current or direct current. In the United States, if something is plugged into a household wall socket, it is using AC. AC reverses direction in the electrical wiring or alternates 60 times per second, or at 60 hertz. If something uses batteries, the electric current flows in one direction only and is using DC. What happens when I am exposed to EMF? In most practical situations, DC electrical power does not induce electric currents in humans. In most practical situations, you see this, DC electric power does not induce electric currents in humans. AC electric current power produces electric and magnetic fields that create a weak electric currents in humans. AC electric, I'm rereading this because, you know, it's sometimes hard to believe that this is right there on their website. I mean, it's officially there. AC electric power produces electric and magnetic fields that create weak electric currents in humans. Being exposed to some kinds of EMF may have some bad effects on humans, but scientists do not know for sure. Oh, the industry didn't pay for its own study. Oh, because of this, NIEHS recommends that people learn practical ways of reducing exposures to EMFs. Okay, let's move on to the next stuff. So reading further down, this is what I copied from ChatGPT. So this is what ChatGPT wrote. The information you provided from the NIEHS website is a good starting point for understanding the effects of DC, AC electromagnetic fields on the human body. So that's ChatGPT, probably version 4, talking about this. I'll elaborate on this topic to provide a clearer understanding. When a person is exposed to electromagnetic field, EMF, the interaction between EMF and the human body depends on the frequency and intensity of the field, as well as of the conductivity of the body's tissues. Both AC and DC EMFs interact with the body, but they do so in different ways. Direct current EMF. DC fields are constant and do not change with time. When a human body is exposed to DC electrical field, the field may include surface charge on the skin, but it does not penetrate deeply into the body. This is because the body's capacitance and resistance limits the flow of direct current. As a result, DC EMFs generally do not induce electric currents in the human body under normal exposure conditions. So, if I understand correctly with this DC, unless you touch the battery with your hands, the plus and the minus, and you short it so that your hand or your body part becomes the wire between the minus and the plus. This is ChatGPT writing this, so probably needs to be verified. However, it probably is pretty clear on the subject. Alternating current AC EMFs. AC fields, on the other hand, change direction periodically. When a human body is exposed to AC electric field, the field can penetrate more deeply into the body due to the changing direction of the electric field. This can induce weak electric currents within the body. So we had in the body electric, remember that book, talk about these electric fields affecting the growth of things in animals. So, and we have an electrical system in the body. So AC penetrates inside the body. So if you're looking to buy a house that's underneath an AC power line, you might have effects of AC electricity that might harm you in the future. So watch out for those kinds of things. Or put solar panels up and try to wire everything DC. Like, for example, there's these RV lights that are awesome that you can install everywhere. You don't have to have AC lighting everywhere. You could put DC lighting. However, it takes a little bit of effort. The RV accessories for wiring everything DC from batteries are available out there. And the things that you need AC for really only is, let's say, for a coffee maker, let's say a stove cooktop, and you could just limit those AC waves just to, let's say, the kitchen where you're making coffee in the morning, and the rest of the time you don't have to be exposed to this, because things like this uses DC. So there's like car accessories that could do DC to DC power. But let's continue reading it. So when a human body is exposed to an AC electric field, the field can penetrate more deeply into the body due to the changing direction of the electric field. This can induce weak electric currents within the body. The amount of current induced depends on the frequency and intensity of the AC EMF and conductivity of the body's tissues. The potential health effects of exposure to EMFs, particularly those induced by AC fields, are still not fully understood. Well, they don't want to understand them because they want to I don't know what they want to do. They just want to make more money. There have been studies investigating possible links between exposure to EMFs and various health issues, but the results have been inconclusive. So says ChatGPT. Like, according to who? It's pretty conclusive to me that we have multiple books over here. We have experts in the AC fields. We have the experts of the electricity. We have another doctor, like multiple doctors talking about this stuff. Okay. So, inconclusive. So that's where we have some sort of stuff programmed into the ChatGPT stuff. As a precautionary measure, the NIEHS recommends learning practical ways to reduce exposure to EMFs. In summary, AC EMF are more likely to induce electric currents in the human body compared to DC EMFs due to their time-varying nature. So, time-varying nature. So, the time-varying nature of the field, think about it like this. All radio frequency waves are also time varying in nature. That's why they can penetrate through a wall. That's why they can penetrate through you and get to your cell phone. They don't get blocked by stuff. So I would say, in a way, AC and radio waves have a similar effect of penetrating the body, as that's how it's understood, at least understood by me. So elaborating more on capacitance and resistance. The human body, like any other material, has electrical properties such as capacitance and resistance. These properties determine how the body interacts with the external electric fields and how electric currents flow through it. I will explain these properties and their implications for DC and AC interaction with the human body. Capacitance. Capacitance is the ability of a material to store electric charge. In the context of the human body, the capacitance results from the separation of charges between skin and internal tissues. When exposed to an external electric field, the charges on the skin redistribute, creating a surface charge. The capacitance of the human body is relatively low, which means it can store only a small amount of charge. Resistance is a measure of opposition to the flow of electric current through a material. The human body consists of various types of tissues, each with various electrical resistance. For example, the skin has relatively high resistance, while blood and muscle tissues have lower resistance. These variations in resistance influence the flow of electric current through the body. DC interactions with the human body. When the human's body is exposed to DC electric field, the constant nature of the electric field causes charge redistribution on the skin. However, the body's capacitance and capacitance limit the flow of direct current. The low capacitance can only store a small amount of charge, and the high resistance of the skin prevents this DC current from penetrating deeply into the body. As a result, the DC electric field primarily affects the surface charge of the skin without inducing significant currents within the body. AC interactions with the human body. AC electric fields differ from DC fields because they change direction periodically. When the human's body is exposed to an AC field, the body's capacitance and resistance properties come into play differently. The time-varying nature of the AC field causes the charges in the body to constantly change direction, allowing the field to penetrate more deeply into the skin. The low-frequency AC fields effectively bypass the skin's high resistance through capacitance coupling, inducing weak electrical currents within the body. In summary, the human body's capacitance and resistance properties limit the penetration of DC electric fields, preventing the induction of significant currents within the body. However, AC electric fields can penetrate more deeply due to their time-varying nature and the capacitive coupling effect, which allow them to induce weak electric currents in the body. Elaborating on dirty electricity. Increasing exposure to high frequency field, dirty electricity introduces higher frequency harmonics and transients into electrical system, which can create electromagnetic fields, EMFs, at those frequencies. Higher frequency field can couple more efficiently with the human body, potentially inducing stronger currents in the tissues compared to regular AC fields. Oh, interesting. So the dirty electricity is pretty bad. Interference with electronic devices. The high frequency noise and transients in dirty electricity can interfere with the proper functioning of electronic devices. This can result in reduced performance, decreased lifespan. Mind you guys, always double check and verify the stuff and get your own books and read them yourself and get your own understanding of this. This can result in reduced performance, decreased lifespan, or malfunction of sensitive equipment. Additional energy consumption. Devices generating dirty electricity can contribute to increased energy consumption in the electrical system. The harmonics and the transients can cause extra heating in the transformers, motors, and wiring, resulting in energy loss and reduced efficiency. As for direct current DC, it is less likely to have dirty electricity because it is constant, unidirectional flow of electric charge. However, the term dirty electricity is typically used in the context of AC power systems. In DC power systems, similar issues can arise from fluctuations, noise, or voltage ripples caused by power converters, battery chargers, or load variations. Such fluctuations are generally less concerning than dirty electricity in AC systems because they do not involve high-frequency harmonics or transients, and their impact on human health is not well established. In summary, dirty electricity is considered worse than regular AC due to the presence of high-frequency harmonics and transients, which can potentially induce stronger currents in human tissues, interfere with electronic devices, and cause additional energy consumption. DC power systems do not have dirty electricity. So DC power systems do not have dirty electricity. So if we don't want dirty electricity, we want to have everything DC powered. However, good news is that your iPad, your iPhone, your laptops, and a whole bunch of things, as long as it uses a power brick, it's already DC powered. You just need to match the voltage that device uses and give it an additional power source, let's say through a battery pack or through a Victron energy converter. Like basically, solar power systems are the solution, or other ways to generate DC, because solar creates DC electricity. DC power systems do not have dirty electricity in the same sense as AC systems, but can have fluctuations in noise from various sources, which are generally less concerning. Okay, so let's talk about living near power lines. The potential association between living near power lines and increased risk of cancer has been a topic of scientific research and debate for many years. Most of the concern focuses on the extreme low frequency ELF magnetic fields generated by high voltage power lines, which can penetrate buildings and the human body. Oh, interesting. ELF, extreme low frequency. Some epidemiological studies have suggested a weak association between long-term exposure to ELF magnetic fields and increased risk of certain types of cancer, particularly childhood leukemia. A pooled analysis of multiple studies conducted by Draper et al. 2005. Be very careful with these when it cites stuff. There was a lawyer that got in trouble because he had ChatGPT write his case and he didn't verify it. So make sure you verify this stuff. Reported a slightly higher risk of childhood leukemia for children living within 200 meters of high voltage power lines. Another meta-analysis by L. Holm et al. 2000 also found an association between ELF magnetic fields and childhood leukemia. However, other studies have not found a significant association between exposure to ELF magnetic fields and cancer risk. So, see, this is how they hide this stuff. So ELF fields, we're not talking about even AC. We could talk about also, anyways. The scientific consensus is that the evidence for a link between power line exposure and cancer is weak and inconclusive. Scientific consensus. So this is scientific consensus. So if you see the stack of books here, scientific consensus, it's bad. ChatGPT, because it's financed by big tech, including possibly Microsoft, that's why. Be very careful. This is how news media, it says expert did this, but they don't freaking cite the expert. Here I can cite you this expert, Dr. Mercola, Dr. this, Dr. that, research scientist, all this stuff. However, they never do this. So scientific consensus, you could take that with some salt. Further research is needed. So you think the industry that profits from this and doesn't want to get sued is going to research itself? And we know the government people aren't going to do it. So further research, you have to do this yourself. I mean, you could buy a stack of books, read it, read the research articles they cite. Big deal. No definite biological mechanism has so they can figure out the biological mechanism. They're stuck in like 1892 or something. And further, while some studies have suggested a weak association between living near power lines and increased risk of certain types of cancer, the evidence is inconclusive, and no causal relationship has been established. So says ChatGPT. So, the potential health effects of AC currents induced in the human body by power lines generating EMFs are now well understood. So, AC currents induced in the human body. So, you have weird electrical stuff going on in your body, and it's not conclusive. So, you have literally wireless electrical fields going inside people's bodies, and we wonder, like, why is everybody like, why is so many people getting a heart attack? I don't know. Who would really know? Hey, boo boo. Regarding DC not generating ELF fields, direct current DC power lines carry a constant unidirectional flow of electrical charge. Unlike alternating current AC power lines, which generate both electric and magnetic fields that vary with time, DC power lines produce static electric and magnetic fields. It's that static property of them that keeps us healthy for people. So I personally went on a, you could say, some people could say, a mission to do as much DC as I could. The term extremely low frequency ELF refers to a frequency range of 3 to 300 hertz. So extremely low frequency refers to a frequency of 3 to 200. Remember, the AC frequency is 60 hertz in the US? So that's interesting. So ELF is basically another definition of the frequency of the AC field. Since DC power lines do not have a time-varying component, they do not create ELF fields in the same way that AC power lines do. How can they create an ELF field? If you need 3 hertz minimum, and there's 0 hertz or just 1 hertz, or like it doesn't change at all hertz, it's like 0 hertz, you can't even have it in a field. However, DC power lines can still generate static magnetic fields due to the constant flow of current. These static magnetic fields are not considered ELF fields because they do not vary with time and do not have an associated frequency. That being said, it is important to note that any variation or fluctuation in the DC current, such as those caused by load changes or power converters, could generate transient magnetic fields with frequency components. These transient fields, if they fall within the ELF range, could be considered ELF fields, but they are generally not the primary concern when discussing DC power line emissions. The main focus for DC power lines is the static magnetic field generated by the constant flow of current. So aluminum blocking. So let's say you decided to put aluminum foil everywhere. Put it on your head, put it on the wall, put it on your desk, put it on everywhere. Anyways, aluminum foil can provide some shielding against electric fields, but is not very effective at blocking extremely low frequency ELF magnetic fields. So ELF is 3 hertz to 300 hertz, so it can block a little bit. However, that's actually what Mercola recommended, is to get shielded AC power cords. So inside they actually have some aluminum foil, so that's why this question was asked. The reason for this is that magnetic fields can easily penetrate most conductive metals, including aluminum. For ELF magnetic fields, the shielding effectiveness of a material depends on its magnetic permeability, which measures the material's ability to support the formation of magnetic fields with it. Materials with high magnetic permeability, such as ferromagnetic materials like iron, nickel, or mu metal, can effectively absorb and redirect ELF magnetic fields, providing better shielding. Nickel or mu metal. Okay, so iron, nickel, or mu metal might be better. Aluminum, however, is not ferromagnetic material and has low magnetic permeability, so it does not effectively block ELF magnetic fields. If you want to shield against ELF magnetic fields, perhaps you just shouldn't generate them in your house and put solar panels up and run everything off DC batteries. That's my comment. If you want to shield against ELF magnetic fields, you would need to use materials with high magnetic permeability like those mentioned above. Keep in mind these materials can be expensive and challenging to install, or you could just use that special EMF paint. So it's essentially essential to carefully assess the need for such shielding before undertaking any modifications. I watched this one video with Off Grid with Curtis Stone, and he talked about how in his house he actually painted the outside of his house with that magnetic paint, and he was able to sleep much better. To summarize, aluminum foiled lined walls can provide some protection against electric fields. So this is against electric fields. However, probably against our radio frequency fields, it could block it much better, but not effective at blocking ELF magnetic fields generated by AC electricity. For shielding against the materials such as high magnetic permeability, ferromagnetic materials are required. Does AC EMF field cause electric field inside the body exposed to as opposed to DC using electric current inside the body? So that's the question. Here's the info I found. Interesting point, quoting that. What happens when in most practical situations, DC does not induce electric currents in humans? So let's get into the Qi wireless charging process. So AC is converted into high frequency AC, then it gets converted back to DC inside the device. So this is one of those toroidal transformers. I should probably link this in the PDF for you guys. I'll see what I could do about that. Or a PDF or on a blog site so that you could read it. Toroidal inverters. Okay, so let's talk about this part. Electric field strength is typically measured in volts per meter squared. Okay, so this is going to help us understand what this meter does. So the first setting over here is going to say volts per meter squared. Volts per meter. So that's the AC. So amps, microwatts. All right, so volts per meter. Let's read up more on this. If your meter measures electric field strength in volts per meter, it can detect the electric field component of electromagnetic fields, including ELF fields. So volts per meter helps us detect the electrical field in the home. That's interesting. Volts per meter. ELF fields are generally characterized by both electric and magnetic fields in both frequency range of 3 to comprehensively measure ELF fields, you would need to meter capable of measuring both electric field strengths in volts per meter and magnetic field strength in either A/M, so basically amps per meter, or micro teslas, which stands for amperes per meter. So yes, this meter can measure this. So for a more complete assessment, so we got volts per meter, units, microamps per meter. So that's the magnetic field. Interesting. So volts per meter is the first part, and amps per meter is the second one. So right now it's microamps. Okay. If you prefer only measure electric field strength, it will provide you partial information about the ELF field, specifically an electric component for more complete assessment. Okay, so we need the magnetic field. ELF fields frequency is 3 to 300 hertz. When assessing the potential impact and health risks of ELF fields, the primary concern is usually the magnetic field component, as it penetrates more deeply into building and the human body. The magnetic field strength is measured dependent on electric field strength and is not directly related to watts per centimeter squared. In summary, ELF fields, the most relevant parameters to measure are the electric field strength, volts per meter, and magnetic fields. So electric field strength and magnetic field strength. Watts per centimeter squared is more commonly used for measuring high frequency electromagnetic fields such as RF and microwave radiation. So we're talking about cell phone stuff, and it's not most important parameter of ELF fields. Do amperes per meter induce an electric current inside the body? Amperes per meter is a unit to measure the strength of a magnetic field. When a magnetic field varies with time, such as in the case of alternating current fields that can induce electric currents in conductive materials, including the human body. The phenomenon is known as electromagnetic induction and is described by Faraday's law of electromagnetic induction. In the presence of various time-varying magnetic field, an electric current can be induced in the human body, causing what is called induced current or eddy currents. The magnitude of these induced currents depends on the strength of a magnetic field and the rate of change in the field, and the electric conductivity and the geometrical properties of the conductive material, in this case the human body. For ELF fields generated by the AC electricity, the induced currents in the human body are generally weak, and their biological effects are still not well understood, so they should be studied. While some studies have suggested potential health risks associated with long-term exposure to the ELF magnetic field, the scientific consensus is the evidence is weak and inconclusive. In summary, time-varying magnetic fields measured in amperes per meter can induce electric currents inside the human body. So the magnetic fields is what causes the currents inside the body. Okay, the magnitude of these induced currents depends on the strength of the rate of change of the magnetic field, as well as the electrical conductivity of the geometrical properties of the human body. The potential effects of these induced currents are not fully understood, and more research is needed to determine any potential risks. Are there safety standards? So microteslas or 1.6 amps for, okay, we're gonna see this. So we have this safety standards. Excuse me guys, I live in the city. I know I want to live in the woods eventually, so we're gonna have to bear with the noise here. So we have volts per meter, okay, change to microamps per meter, and we have 1.6 amps. So this is probably 1,000 times less, so I'm not sitting underneath an electromagnetic field. So that's what we understood here. Volts per meter is the electric component, and this is the magnetic component of whatever electrical fields we have around there. There's probably some earthly ones too. However, this one varying around like this is probably from some sort of AC somewhere running nearby somewhere. So let's move on. So WHO, I don't care who they are, keep in mind they're for general public exposure. Occupational exposure limits are typically higher. Strength of electric field. So again, ELF range is 3 to 300 hertz. By the way, this guy, for example, can't detect 5G because it can only do 10 megahertz to 8 gigahertz. Oh, that's interesting. If it can do 10 megahertz, can it even do this low electric field? Maybe it can't. Interesting. So, because 5G is much higher than that, it might not be able to detect it. So AC power systems include operate at 60 hertz, which falls within the ELF range. Okay, so we understand that. Is there more ELF from 400 to 240 volt? The ELF generated by depends on the current flowing through the system and the design of the wiring devices rather than the voltage. In countries with the standard voltage is 240 volts, the AC power system is typically operates either 50, just like countries with 120. The primary difference between is the voltage level. The current required for a given power level is lower in the 240 system compared to a 120. For example, a 2400 watt device with a 10 amp draw on a 2 would generate 20 amps on a 120. Since the magnetic field strength is proportional to the current, the higher current in a 120 field system could in some cases generate stronger magnetic field than a 240 system for the same power level. However, this also depends on factors such as the design of the wiring, the distance between the conductors, and the presence of other devices and sources of ELF. That's interesting. It is important to note that both 50 and 60 Hertz AC systems fall within the ELF range. Okay, what is the cheapest you could buy online to block? It is important to note that shielding against ELF magnetic fields can be challenging, as these fields can penetrate most common building materials, because that's the magnetic thing. Perhaps one of the conclusions that I just came up with in my mind is the compass works indoors or outdoors. The magnetic field can be really shielded against, technically, unless maybe you go to somewhere where it's much lower. Maybe lead can do it. I don't know. So that's challenging. Mu metal is a nickel iron alloy with high magnetic permeability, which makes it effective at attracting and redirecting magnetic field lines. This property allows it to provide some sort of shielding against ELF magnetic fields when placed between the source of the field and the area you want to protect. Mu metal is available in sheets of foil and can be bought online through various retailers such as Amazon. Okay. Please note the effectiveness of mu metals in shielding ELF fields depends on several factors, including thickness of the material, the size of the shield, and the specific configuration of the source and the area you want to protect. ELF fields are generated by various sources, including power lines, electrical appliances, building wiring. In rural areas without power lines, the ELF fields get generated by these large sources of electromagnetic field sources are generally expected to be lower than in urban or suburban areas with more extensive electric infrastructure. What is the minimum distance where they're not detectable? There's no specific minimum distance from power lines at which the ELF fields become completely unnecessary, as the strength of the magnetic field depends on the various factors. In general, the strength of the magnetic field decreases with distance from the power lines. The rate at which the field strength decreases depends on the material specific configuration of the power lines, such as whether they are single phase or three phase, or whether the power lines are bundled or spaced apart. As a rough guideline, the magnetic field strength from a high voltage power lines can be decreased by magnetic levels of 0.1 or lower at distances between 50 and 300 meters away. So if you're 160 to 985 feet away, you probably won't feel the field anymore. For lower voltage distribution lines, such as those found in residential neighborhoods, the magnetic field strength typically decreases more rapidly with distance, often reaching background levels within 10 to 50 meters, between 33 and 164 feet or less. Okay, to convert magnetic field strength. Okay, that's all that stuff. A reading of 4 microamps MA on your meter is lower than the typical background level of the Earth's magnetic field. Really? Which is about 25 amps per meter. What? I'm not sure about this. This part is kind of confusing. So we have these 5G towers. I believe they're 5G towers on top of people's homes. Notice there's an apartment below with an air conditioner, and it has that cell phone antenna on top of it. We saw an article earlier where these kids that had an antenna across the street from them getting cancer. However, what happens to these people with a 5G antenna on top of the thing? Why is this a 5G antenna? It's because 5G waves have to have kind of like a line of sight. So this can be visible from the street below, and it can send direct microwave signal right to your 5G phone. And this is all across the town on people's living homes. Here's another beautiful example of what I mean. We have that beautiful antenna right on top of the building, giving people clear access. However, those people on the 6th floor are getting the effect of that. What's apropos about this video is that above that we have chemtrail with barium and aluminum and all this other stuff that's getting into people's air and water. So that's another example of what we have with the state of the cities in New York. I bet it's probably similar to different towns. I don't know these people. However, I wish the best for them. Maybe that they get the tower removed from the top of their heads.
But others didn't take notice. I just walked right past it. I have not seen it at all. This new Link NYC 5G kiosk was unveiled on West Burnside Avenue in the Bronx. It's similar to the smaller Link NYC kiosks you see around the city. You can make free phone calls, charge a device, and connect to Wi-Fi. But the bigger kiosks offer better 5G connectivity.
It's all about faster internet.
Matthew Frazier is the city's chief technology officer.
Up to 750 feet away, you could get access to the old versions of the free Wi-Fi kiosks. The new versions of it, up to 1,000 feet and a little bit beyond, depending on what's in the area.
He says 90% of the 2,000 new kiosks will be placed in the outer boroughs and above 96th Street in Manhattan.
What we want to make sure is, as we bring this technology out, the people that have the greatest need are those that have first access to it.
79, and I don't like to go out on my phone. So if I have to make a phone call, I can do it.
Kids, they have to use it for school, the computers, and I think it's great.
So far, there are 20 in the ground, 2 live and active in the Bronx.
I live right there, the building right there, upstairs on the 5th floor, and I didn't think it could reach that, but it did.
Anthony Cruz says his kids have been using the Wi-Fi, and it's much faster than the internet they have at home.
I think it's good because some people, don't have money to pay for internet. I just hope they keep it.
The city says dozens of these 5G kiosks will be deployed by the end of the year. In the Morris Heights section of the Bronx, Jenna DeAngelis, CBS 2 News.
Now, the city plans to have all 2,000 5G kiosks in the ground by 2026.
And that will bring the total Link NYC network to 4,000 locations citywide.
So, wow. After watching that, reviewing this video again, with this small of a tower, this article is probably from 2019. This is 5 years ago. We had this small tower contributing to the kids getting cancer in that school. And then we just watched this video with probably the entire thing as a 5G tower. My God. Wow. What are people in for? And you think anybody's measuring it? They say it's up to federal standards. Where did they measure it? Did they measure it at the school? Did they measure it from the parking lot? Did they measure it from like a house over here? Makes you think. All right, friends. So this is the desk of my computer in my home. I have a laptop over here, connected to a wired connection via USB port. And we have 1.7 volts per meter on the table. Unit, change this, microwatts per centimeter squared. We got 1.33. So I believe that's a lot less than we have outside. I believe we were getting in the 10 to 15 just sitting there. In my bed, for example, I have even lower. Volts per meter, 1.33. So let's do this experiment. Because we have minimal waves here, we don't have Wi-Fi on, or we don't have Bluetooth devices. Let's take this guy off airplanes. Let's see what this guy does. That's volts per meter. Oh, this is just without the wireless internet. Now let's turn on wireless internet. Boom. Now let's turn on Bluetooth. Boom. Now let's turn on Wi-Fi. There you go. This is what people are dealing with all the time. Right next to their head. Maybe the back has better transmission, see? 1718. That's before even the video goes playing. Now let's play a video.
100 watt.
Oh, we're doing volts per meter. Okay.
Bifacial.
Let's actually switch the unit to microwatts per centimeter squared.
What ostensibly is the front or possibly the back.
So remember we had less than 1 before.
Saying that the open circuit
or like
is
1.5.
22.4, max operating 19.1, and this might be the front or the back. I'm not even sure. And this is where there's this little box with the bypass diode.
Okay.
This is the other side. What does bifacial
So let's
mean?
see.
It pretty much means that solar could be generated.
Let's see if we could put this on airplane mode.
So I came up with a test where both
So now
are
it's
connected.
airplane mode?
They're both at the same angle, but one is facing the front.
You see
and one
that?
is facing the back. So one is facing one side, one is
0.47.
facing the other side. So what power generation does it have? What is the size
Take it off
of
airplane mode.
And let's have fun. First, let's start with the sizes. So this thing is about 40 and a quarter. I would say 40 and a half, just to be safe. From the top to the bottom. And what is the width? Let's see this. The width is...
Ooh, ouch.
About 22 inches.
That's a lot. Okay.
So 41 by 22. Okay. Interesting.
Now let's
look
change
at
the
build
unit
quality of
to
it.
volts per meter.
What I like about this panel is that it has this aluminum
Now let's
framing
do-
around it with these
Boom.
holes. Hole here, hole here. There might be some sort of
1.34.
plastic on the other side to be peeled off.
So
Let's do
that's
that
AC
together.
energy field.
Let's peel
That
this
just jumps
part
up.
off. If it lets you. Or maybe that's not to be peeled. I don't know.
So what I'm
Well,
presenting to you here is
This
a
is some sort of
typical
peeling going on.
situation
Okay.
where people have the Wi-Fi, the wireless internet,
So
and the
it's,
Bluetooth on,
charging up.
and they're watching a
600
video.
watt bank. I'm kind of like blocking out a
And
little
similar
bit.
idea is if you're,
Okay,
you
95.
know, talking on the phone. However, it's
With me
still
blocking
less
this much.
than having all 3
one of
frequencies
them.
at once.
That's what 2 panels connected. Okay, so what we're gonna do? Let's experiment.
That's volts per meter.
Let's put this guy here.
Now go to the
And let's put
microwatts per
this guy
centimeter
here.
squared.
As much of an
Wow,
angle as I
94.
can. That's
94.
gonna be close enough.
Boom.
And with me in the middle, let's see what we're producing.
Whew. That's much better. 1.02. Unit. 1.37. Not 16. So now let's talk about mitigation strategies. So this part is plastic, 5.5, right? There's nothing but plastic and like a netting from the things. And over here we have aluminum. Oh, that's volts per meter. Let's do microwatts per centimeter squared. That's the radio frequency power. 5.6 over here. And over here we have aluminum shades. So that lowers it a lot. So number one, you could get aluminum shades. They mitigate the amount of radio frequencies that come in. Now then, let's talk about networking stuff. You may want to... Alright friends, all hope is not lost. We just saw in this, a little bit earlier, that you can get the EMFs lowered in your home and I did it, and I just showed you the numbers. So what are some of the things that I have? Here, for example, this is a switch. I got the best of the best. This is fanless, and this is 10 gigabit. Perhaps you might just have one of these for your entire house. It has both fiber optic and copper cables. This is the stuff I really like. So yes, you don't have to get the most expensive one. The idea is that a switch could provide all these ports that you would need in order to wire connect to your devices. Like, for example, an iPad like this would get one of these wired connections to a USB-C hub that has an Ethernet, and it also has a power supply to it. So this cable supplies both power and internet to this iPad, and it uses up one of the ports. My MacBook uses another port, another PC uses another port. I have a device for my iPhone, a lightning adapter, that uses up a port, and these 10 gigabit SFP plus ports, you could use that for the fastest internet connection. This is why I got this, is that every port gives you optimum connection. Next, most people have wireless routers. However, this one is not a wireless. This is a lie. This is not a wireless router over here. I have this device. It does have a fan. You don't put this next to your ear when you sleep. You put this in your living room, and it doesn't have a wireless connection to it. There is a possibility where you could get one of those other wireless routers and just turn off the wireless connection. Like, for example, with the ASUS wireless router that looks like a flying saucer, I was able to turn off the internet connection on it and the wireless internet connection on it, and it worked fine. However, in there, you have to go to the settings to turn off also guest Ethernet connection, because that has a separate Ethernet, for some reason, connection. If you turn off your main internet, why would you want to keep your guest internet going? I don't know. Or vice versa. This is a USB-C hub. So on one end, I have this USB-C wire connected to this end over here. And I just have an Ethernet wire. It looks like a phone jack into it. And over here, I have plugged in power connection to give my iPad power. So this both charges and gives my iPad internet. This wire is quite long. I could use it on bed. It's probably not as convenient as using it wirelessly. However, why would you want all that extra signal bombarding you for no reason, especially if you're a child? This is the good USB-C cable, sideways made. So 10 feet is like super long. You could get a 6-foot one or a 3-foot one. So that's really a good idea. And lastly, this stuff I think you have to get on eBay. I just searched for Belkin Ethernet Lightning. Belkin Ethernet Lightning. And this is for your iPhone. iPhone up to, I don't know which one might use a USB-C. However, if you have less than a 14 or a 13, you still have that lightning connector over here. So that provides power to the iPhone, and that provides internet. So you could connect this Ethernet dongle to your iPhone and get internet on it, and use that to like connect to the network, transfer pictures. This is a more convenient and more stable connection than you would get from a regular wireless connection. So you don't have to have Wi-Fi. So I just showed you how this same thing you could into the USB-C hub, you could plug in a 100-watt adapter and power a MacBook, or you could just plug in the Ethernet wire directly into your laptop or your desktop computer and go to the Windows settings and disable the wireless and the Bluetooth. That's if you want to. I mean, you guys do you. I'm just showing you options that you could do that I personally have done to mitigate the situation. And lastly, also, you have to note that you see this over here, when you go to turn this off, this turns off completely. However, this guy stays gray. Why does it stay gray? It's because it's not fully off. You have to go into settings on your phone and go to the actual Wi-Fi and the Bluetooth and turn it off from there. Same thing with the iPad. You would have to go and turn it off from inside the settings menu, because from this menu it just turns off that signal unless you put it on this mode, which you don't have even phone access. With this mode, if you have both of these guys turned off, also when you're restarting it, or perhaps get an iOS update on your iPad or your MacBook or something like that, it automatically has Wi-Fi on. So that's another Wi-Fi mitigation strategy you could have. All right, friends. It's been a long time. I've been explaining a lot of this stuff to you. To summarize it all up, we're surrounded by different types of electromagnetic waves. Bluetooth, Wi-Fi, AC power, like in the house, where we have all these AC cables running through the entire house. Most of the culprits is probably your Wi-Fi, your smart TV. I used to have a Samsung TV. This is before this ASUS 43-inch, I think, OLED monitor. This is a monitor. It doesn't have any of the smart components that your TV has. What does a smart component mean? It means there's a little computer in there. However, if you read into the license agreement, it says that it could broadcast to whoever, voice and video, whatever it wants to share it. Long story short, Samsung TV, I have it turned off. You press on the remote control off, it's off. I'm walking around with my meter, and I'm like, why is there a signal? So not until did I unplug my old Samsung TV did it actually turn off the Wi-Fi signal. I had it completely router wired. So what you're gonna find is certain devices, if they have a Wi-Fi chip in them, and you go to the settings, you think you turned it off, it may not be turned off. Unless you have a meter, you could tell. So with that Samsung TV, well, I got rid of it since I replaced it with this. However, what I did wind up doing is I took a screwdriver, I opened up the back of it. Every TV, probably, just at least the Samsung did, it had a little wireless Wi-Fi chip. Sometimes it gets burned out. You could find on YouTube ways to replace it. So what I did was I just went inside the TV and I unplugged that wireless Wi-Fi chip. I turned off that smart functionality to completely broadcast it. Even if you have it off, even if you have a wired connection, an Ethernet connection to it, it's still gonna keep broadcasting a Wi-Fi signal. I don't know why I did that. Also, I had an indoor growing, like vegetable growing kit. It had Wi-Fi in it, so I turned the Wi-Fi off. Come there with the meter, it's still broadcasting a Wi-Fi signal. I go in the menu, I turn the Wi-Fi off, it's still broadcast a Wi-Fi signal. So, best way to put it is it's a good idea to have one of these meters if you're very, very not concerned. If you're very concerned with getting rid of all the Wi-Fi signals in your house. If I didn't have those meters, I wouldn't know my TV was broadcasting this. I want to be able to remember that the stuff, like for example, Mac update, boom, it turns the Wi-Fi on restart. iPad update, Wi-Fi on restart. So be very careful. You have to go to the settings to turn it off. Perhaps you're expected to use the wireless connection with it. However, we did go into the legal RF exposure. It talks about using the headsets and all that stuff. It doesn't say wireless headset, by the way. It doesn't say, it says headset. To mitigate the RF exposure, use a headset. Does it say wireless headset? Does it say EarPod Pros? Does it say Bluetooth enabled headset? It says just headset. So I got a feeling they're covering their butt there, because a headset could mean many things. And it's probably logical that if you don't want radio frequency exposure, you wouldn't put a radio frequency inside your ear for hours at a time. Also, those cordless phones. Behind me is a corded phone, by the way. That's corded. That's with a cord. Cord. You know, kids don't they? What's a cord? Mom, Dad, what's a cord? It's one of those things. You punch those buttons. So that's a relic. I barely use it, sure. However, you could have a wired phone. There is a type of phone, a business phone you could order, code OBI 2082. You can connect it to Google Voice, and you could have a house phone line completely for free. And you could have this house phone line ring your cell phone and a house phone at the same time if you wanted to do it. It's kind of like a forwarding service. I mean, thank you, Google, for like providing these services. I really love the Google Fi service. Perhaps I'll add like a link that you could get like a $20 discount. You get a $20 discount and I get a $20, something like this. Maybe a $10. I don't know. Doesn't matter. Google Fi service is good for because you could get the SIM and for like wireless things. So one of the things you could also do is with your iPhone, use the lightning connector, use the EarPods, the regular wired headphones. Perhaps they have a little bit of EMFs, but I don't worry about that. There is, like, if you want to get really methodical into it, there's some sort of headphones where it's kind of like hollow and it broadcasts the sound through a tube, so you don't get any electronics in your ears. But that, to me, that's way too crazy. I just get a regular headphone, plug it in, lightning connector, or if you're on an Android, connect the wired headphone. I mean, just think about the ease of use. Okay, yes, it's more comfortable. The cord doesn't catch on everything. That's the annoying thing about having a cord. It sometimes catches on a doorknob, catches on a shelf, catches, I don't know what it can catch on, anything you want. However, you're not getting EMFs in your ears, and you don't have to charge a battery, and you don't have to spend $200 on it. The EarPods Lightning headphones, make sure you always get them from BestBuy.com, because Best Buy has the real ones, and on Amazon, they're fake. So put the headphones in the ears, go for a walk. When you're going for a walk, have your internet off. I mean, do you really need the Wi-Fi and wireless broadcast signals broadcasting through your reproductive organs? Say you want to have kids, maybe that affects them somehow. Look, there's people that go around that say, oh, it's completely within a wireless radiation range. However, just think about it like this. When you come up to the tower, the radio tower, the radio station, 5G, 4G, 2G radio station, when you're standing underneath the tower, it's probably the strongest signal. Then if you are a mile away in a car that is like partially metal, let's say, like it has to go through all that, the signal is much weaker. So how do you put a 5G tower next to people walking? And then one of the most egregious things is I'm walking in my neighborhood, and right across the street, of course, it's right across the street from an elementary school in front of a bank. And in front of like a fruit grocery store. So people decide to be healthy and go buy some fruits and vegetables at the local grocery store. And that's what they get. They get a freaking 30-foot tower broadcasting signals to them 5G, 4G, Wi-Fi's, all that stuff. Can you like be completely blind to it? Yes, I can't see the stuff, like the signal. However, you know, like when you drink water, like tap water, make sure you filter it, because A, the pipes are old. You know, you don't know what's like kind of gunk is in there. B, there's chlorine. They've given men, young healthy men, 20s, like soldiers, boom, chlorine tablets in their thing. Couple months later, after doing this, like multiple times probably, these guys had the veins and the arteries of an 80-year-old, like 20-year-old men. That's because of the chlorine. And some people just get that chlorine glass and go, 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 go. But not to mention the fluoride. You know, why is there, like, if you look up fluoride and it has, like, you know, danger, rat deleting agent for getting rid of rats. Like, you could see sodium fluoride, you know, there's bags of it, and it's in the water. But people are blind to it. They can't see it in the water. The water looks clear. A little bit of cloudy from the chlorine. It is what it is. Well, ideally, the EMF mitigation could be done like this. Okay, you get your own farm, you get your own land, you go far away from these towers, you put solar panels up so you don't have AC low frequency waves from all that AC flowing through your wires. So the only place you would have AC would be probably in the kitchen or in certain places produced locally to, let's say, power a TV. Like TVs like this guy's AC. I have to plug it into an AC outlet. And that speaker too, I need to plug it into an AC outlet. If you have a desktop computer, you need to plug it into an AC outlet. That's fine. However, you could put that locally. You could put what's called a power inverter and run off batteries. So batteries are DC. Solar panels are DC. You could run all these wires across your house, learn how these RV people do it. They have a very simplified systems. It's completely safe. You could get the 12-volt version. So even if you touch it, if you put your tongue on it, you're not going to die. It's the higher voltage ones that might be like more worrisome. However, probably still fine. And you can wire that up. So that's probably the ideal situation. You're on a farm. You drill your own well deep down. There's a thing called primal water. Apparently, we have more fresh water under our feet, like deep down, than perhaps in all the oceans. There was a guy that did a study. He found that, like, a mountain up high, you can still get water, and it's not groundwater. It's some sort of primal water. It's underneath rocks, all over the place. I'm just talking about the entire health. So we have that. For your internet, of course, you want to have internet. I want to have internet. And how I watch videos is I watch them on my screen, on my laptop, on a PC that's connected to YouTube. And I could also go on Amazon Prime. I could watch movies there. It's great. And there's a thing called Ad Block ER. Ad Block Plus. But, you know, that installs on any browser, and you could have a more hassle-free experience enjoying your YouTube videos. Very nice. What else? So instead of a TV, you could get one of these OLED monitors. Ooh, ASUS. This, I've never watched more better movies than with this guy. And I have a full-fledged PC with a gaming thing card on it. It's fantastic. Or on my Mac Pro, 16-inch. Mwah. All wired up. I don't have a wireless signal. I can sleep well. I know it's not affecting me. Hey, I told you, like, whenever I get to exposure to too much EMFs, I can actually feel it in my heart. Perhaps maybe you do too. Perhaps maybe you think, oh, it's just like, whatever, it's normal to have these issues. But when I stop doing it, stop using it, it kind of gets better. So it's kind of weird. Maybe psychological. I mean, look, I can't measure how much signals, and we saw with the meter, the way that it works is it goes up and down, up and down, up and down. You don't know how much signal. It's like, oh, it's completely within safety limits. Okay. Safety limits at one point. At the lowest point, when there was no video being played or after that when the video was being played, because those were two different numbers. There's no kind of like steady state that these signals work on. How good was the cell phone reception? Was it a 1 bar? With 1 bar, that cell phone is struggling to send that back and forth. It's probably going to show off the charts on the meter. But nobody asked that, because you can't have a uniform amount. And then you have a water balloon instead of like an animal being tested on with the wireless signal. So you're the testing guinea pig? Oh, but don't worry. The industry will control itself. Yeah. Because the politicians, they're not bought and paid for. They're completely not in the pockets of any corporations that's adding any chemicals to any of the food, making people fat and hungry, and making them want to eat more and more and more food while watching the stupid 5G smart TV with the stupid 5G tower outside their house, with a 5G tower on their head on the 6th floor. I mean, this is not a city. This is kind of like, it feels kind of like an intrusion into my body, because I know these wireless waves could go through my body, because that's how things work. They go through. If we had just DC electricity, if we had fiber optics everywhere, I mean, it's possible to do. I showed you what things to buy. Yes, I was showing you the most expensive one. However, how much is your health worth? There was a Chinese phrase. It's ridiculous. You people in the West spend all your health on money, and then you spend all your money to try to gain back your health. Hey, let's not hurt the health. And then we have these wealthy people. They know something that, hey, okay, let me put it to you this way. Do you have $1 billion? I'm still waiting for my check. However, if a guy has like $1 billion, has started multiple companies, is in the tech field, is super smart, like wrote computer networking things or hired people to do computer networking things. They're pretty smart in the things. And they're not letting their child to have a cell phone until 14 years old. So what are you doing giving an iPad to a baby? Steve Jobs didn't give an iPad to a baby. He didn't. Steve Jobs still died of cancer, though. That's sad. However, probably he's like, you know what? Maybe he was around too much EMFs, and maybe that's what hurt him. Who knows? Maybe he was predisposed to it. You know, it's kind of like a nature versus nurture thing. Some people will be fine. You know, some people dose of the stuff from their signals is probably fine. However, how do you really know? Does anybody else have a meter? I'm probably the only one of my friends that has this meter. Yes, I spent like over $400 on it. It's $500 now. Taiwan made, fantastic meter. I love this meter. So I can get my AC electricity at volts per meter. I could get the other fields going, and I could measure the stuff going. So until I was able to measure the stuff happening in my home and be surprised that my stupid Samsung TV was producing EMF waves, even when it's off. Like, why does it need to broadcast a Wi-Fi signal when it's off? Why does a stupid plant feeder, an indoor planting thing, need a Wi-Fi signal on it? Yes, I bought the most expensive one. Stupid idea. I like the nice tech. I'm like, you know what? I like the little screen. I could probably turn off Wi-Fi. No, you couldn't turn off Wi-Fi. Well, I could probably rant on and on and on. So what are the mitigation strategies? There's also, I think it's called BioShield paint. There was like a Switzerland company that has some sort of paint. There's something also with grounding, like if you put like an EMF protection mesh on your thing, if you put it into the neutral, into that, not the hot wire, into that ground wire, or attach it to a pipe that goes in the ground, somehow the electrons could actually flow down, and that does a better EMF mitigation, especially if you use the paint. think it's called BioShield or whatever it is. It's like this black paint. You paint it on your wall, and then you could paint your wall with a primer and paint it white. But you put like kind of like a wire into that, you know, grounding thing. So perhaps that, perhaps other metallic objects like maybe aluminum, maybe it could work. I don't know. As we see, the AC stuff can't really be mitigated. That's the AC electricity that we have in our computers, in all our homes. So the only way to do it is doing off-grid systems. And even that, with an off-grid system, I see all of them using inverters, but I would just convert everything to RV electricity. So let me put it to you this way. Back in the day, they used to use kind of like x-ray machines to photograph people's feet. And you had this stuff in shoe stores. Wow, decades later, they found out it wasn't good for you. However, people normally would be trying on shoes and would get their feet x-rayed. And how bad it was for people didn't realize it any better. So I got a feeling this is with the new technology, reading the books, that with the more and more electrification of our society, the more diseases that could come up, and the more diseases could be mitigated if we use the right technologies. However, we realize that these corporations, you know, people not looking after them, and the people aren't doing anything smart too. They're walking around next to this 5G tower and like, it's okay. My kid isn't at school, but it's okay. It's probably fine. Don't worry. Somebody got it. Somebody got it. No, there's nobody looking out for you except yourselves. You tell others. You learn this material yourself. You get the books. You read the books. You get a meter. You think about what you could do. Switch over instead of to a regular router. You could get tiny little travel routers. And if you really need Wi-Fi, connect one by your bed. Connect it when you need it. Get the Wi-Fi signal. Get whatever stuff you do. And then once you're done, when you want to go to sleep, just turn it off. That's my solution, guys. I mean, I wish I had all the answers. I already did put the time into getting the thinking regarding this whole signals and how they interrelate between each other. And I learned a lot myself. I'm glad I made this video because this whole AC signals and all these things that propagate into us could be affecting us, because, you know, it says on the websites there's like electrical fields happening in our bodies, and it's probably messing with our own natural electrical fields. So I'm wishing you the best. I'm wishing the great blessings for the eyes, for the people with the eyes to see and the ears to hear. So I hope you hear it, and may it bless you, may it find you well, and may you take this advice. Maybe just a little bit of it, maybe an ounce of prevention is worth a pound of cure. I'm hoping for that. And hopefully this video will stay on YouTube and nobody takes it down. So there's always BitChute and Odyssey to see it too. Thumb it up. See you in the next one. And I have other videos, like the router that I recommended. I reviewed it and I talked about it and what were the recommendations to it. And you can do it. Just know this. You can do it. It doesn't take much genius to do it. Just take the path of somebody else. Read the books. Read those great scientific doctors with all their literature, with books citing so much citations. It would probably take a lifetime to read it all. So I'm excited for you. The journey is just beginning. You can do it. You can also live an EMF-free life. And hopefully we talk in 20 years and you say, hey, I'm really thankful I watched your video. And I'm thankful I took your advice. All right, friends. God bless and see you soon. Bye.